In this video, we'll talk about applying the chain rule multiple times to solve a problem. So sometimes you need the chain rule more than once, right? You can apply the product rule multiple times, you can apply the quotient multiple times, you can also apply the chain rule multiple times to solve problems. The way to think about this is, again, using the outside-inside rule. So you work for the chain rule normally, we pick our u, you write this outside function of u of x, and then you have f prime at u of x, and then I need to find u prime of x. Well, what if this process here also needs the chain rule? Well, that's totally fine. I now have a new problem that is find the derivative of this u. And if that is a chain rule, so be it. I'll set that up as a composition and do the same rule again on this u of x to find its derivative. You can also process this as sort of an extended outside-inside rule, where if I now have, say, a composition of three functions, so I have an f of u of v of x that I want to differentiate, I can do it by just extending the steps further, right? So I would first do f prime, and I would plug in everything inside of it. Now I go one more step in. I need to differentiate the u part in the u of v of x. How would I get that? Well, that would be times a u prime, plugging in whatever's left, plugging in v of x, and then step down to v prime of x at the end. So if you want a formula, that's how you can write it as a formula, but the really point is I'm moving the derivative one level in every time until I'm done and get all the functions that I have. Let's see an example where this occurs. So I'm going to find the derivative of the function cosine squared of 3x to the fourth plus 5x cubed minus 2. Now the notation here can also be kind of deceiving, so I'll write it a different way so we can see what's actually going on here. This L of x can be written as cosine of 3x to the fourth plus 5x cubed minus 2 all squared. So basically, in order going outside to in, I have a u squared function. That's these brackets on the outside. Then I have a cosine function inside that. And then I have my polynomial. This has three functions built into this, which means I'll need to apply the chain rule multiple times to get this answer. So I see u squared, I have u, which I want to set equal to cosine of v, and then I have v, which equals this polynomial. Let's find this derivative. Start from the outside, we see a u squared, that should be 2 times u, times, the next inside part I see shrinking down a little further, is now a cosine function. The derivative of cosine is minus sine of v. And then one step inside of that, I see the polynomial. So that derivative is 12x cubed plus 15x squared. And I want to convert everything back to x's because that's the variable that I have on the other side of the equation. So I should get here 2 times u is cosine of v, v is 3x to the fourth plus 5x cubed minus 2, times a negative sine of v is 3x to the fourth plus 5x cubed minus 2, and then that part on the end still 12x cubed plus 15x squared. I can then recollect my terms a little bit, and I will get a negative 2 times a 12x cubed plus 15x squared times a cosine of 3x to the fourth plus 5x cubed minus 2 and a sine of 3x to the fourth plus 5x cubed minus 2. And so that's what I would get for the derivative of this function using the chain rule multiple times, stepping through outside in every step to finally find the derivative of this function. Be careful when you're doing these problems to make sure you hit all the steps you need and get everything done with the problem, but if you step through it one at a time, you should be able to eventually get to the answer for these complicated chain rule problems.